Maybe we should go to Science 9 instead. Science 9, that looks better. So we are on page 46, but I'm going to write out the examples without the stuff there because sometimes it's easier to understand if you see how it works. Okay. So here we have CaCO3. How many elements are in that compound? And how can you tell? There's 3, and we know that because we have 3 different what? Capital letters. However, our names should always only have 2 names unless we have one of the ones that has a double barrel name that I'll show you. So almost all compounds have only 2 names. I'm going to put all compounds should have only 2 names, and then I'll make an exception. And if anyone needs these notes printed out at the end, just let me know, I can do that. And in fact, where did I put it? If you were away over the last few days, so either yesterday or before that, I do have some notes photocopied for you. So Roy, anyone else who was away, Alyssa, or if you just want them, if you're like, you know, I would just like a copy of the notes. Anyone else who just wants one? So I can do the same thing for this one. Anyone else while I'm here? Yeah. So now the reason I have the little star is my exceptions involve ions, involve polyatomic ions, like hydrogen carbonate, which is only a single ion, HCO3 minus. So anytime you have 3 names for a compound, that is going to involve a hydrogen. Okay, and it will be one of the ones that just has the name hydrogen. if we go back and say, where are those ones? You see all the ones here where we have HCO3, HC2O4, HSO4, HSH, SO3. They can all be named hydrogen carbonate, hydrogen oxalate, hydrogen sulfate, hydrogen sulfide, or hydrogen sulfate. Or they can be named with the bi instead of the hydrogen. But if you see 3 names, it means you have one of these that has like a 2 name for a single ion, okay? But if you're not concerned about that, if you're like, I'm okay with being right 95% of the time and I don't want to worry about the other 5%, all compounds have only how many names? 2. All compounds have how many names? 2. All compounds have how many names? 2. Okay? All right, back to business. There we go. So, if we only have 2 names, that means we can only have 2 ions. So our first ion, where does our first ion end? Tell your partner what letter is the last letter of the first ion in this one here. What's the last letter of the first ion? A, because we have CA. That is our positive ion. That means that if we only have 2 things to name, everything else has to be the negative ion. Now, you guys know what Ca is probably by this point. Who's Ca? Calcium. So we can do that. That's easy. Calcium. Now, where would I look to find CO3? You're going to look on your pink sheet. So if you go look on your pink sheet and you're looking for CO3, it's probably in the C's somewhere. CO3 is carbonate. And all you need to do for that is just name it carbonate. You don't change the ending. You don't do anything other than just naming it. So, carbonate. How many names did we end up with? 2. Calcium and carbonate. All right, in our next one, actually I should give myself more room. Can I do this thing? Hang on, let's see if it works. No. Oh, hang on. Just let me try something. Can I loop? Oh, lasso. No. Nope, that didn't work. Sorry, I really shouldn't try and do this when you guys are waiting for me, but let's try it anyway. Oh, here we go. Oh, look, I can do it. Yes. Nope, that didn't work. Okay, hang on. Try it one more time. Yes. Okay. I feel like most other teachers probably know how to do that automatically, but I've never done it before, so it's new for me. Okay. So now we have example number 2. We have MgOH2. How many elements? Tell your partner, how many elements do we have? We have 3, we have Mg, we have O, and we have H. How many names should we have? 2 names. So what that means is that you're going to put a box around your metal, and everything else is a polyatomic ion. A PAI, a polyatomic ion. So we're going to then name magnesium, which we all know. Hopefully you did, otherwise I just gave it away. Magnesium. Could you all please go onto your pink sheet and look up OH? OH minus is hydroxide, yes. So we know that we are now going to name that second part hydroxide. And that's it. Oh, this time I don't have a metal at the front. What do I have at the front? I have ammonium. So the first thing is, the cation is always going to be a metal or ammonium. And in this case, we have ammonium. If you can't remember its name, where would you look? You would look on your pink sheet, okay? It's one that gets used fairly often, so lots of people just start to remember it over time. But if you don't know it, look it up. Now we have SO4. Where should we be looking for that? That again should be on the pink sheet. Who is SO4? That is sulfate. So the name is ammonium sulfate. Now here's one last one. Although maybe I'll do one after this to make, because there's some that look like really crazy. Okay. Who is the cation here? That would be Ag, which is the metal. That's our positive ion. And then that means we have CrO4. So who is Ag? Silver. And CrO4 is chromate. Again, just go look that up on your table. Do you want to see a really weird one? Whoa, so many letters. Yeah? So many letters. But we will still only have 2 names. So who is the cation? It's ammonium. That's NH4, ammonium. So we can put a box around that, and we'll name that. That is ammonium. And then we've got this CH3COO. It's really long, but it's really just one thing. Okay, whenever you're finished with your cation, the rest of it is all just a single anion. And what is the name of CH3COO? It is acetate. Now this is the one where, if you remember, there were two different names, and you can use either of them. Acetate is by far the most common name. So if you don't like ethanoate, you can just ignore it, okay? But you'll see CH3COO is there, and it is there. Your choice. Which one you use, okay? So that would be ammonium acetate. Now there's one more little hitch that I think I'll at least, talk about today so that you can maybe do quiz number 5 today, because quiz 5 also deals with naming these ternary ionic compounds, and ternary is just a fancy word for 3 or more elements. You don't really need to know that. Basically what it means is compounds with polyatomic ions. This is on page, oh, let me find the page, please. 49. So this is for compounds containing polyatomic ions. This is a good review. If you haven't done quiz 4 yet, you're going to be like, oh, I need to figure out how to do Roman numerals, because it is those multivalent metals that need Roman numerals. Where do we find the multivalent metals, the ones that need the Roman numerals? They are found in the gray zone. If you don't know the name multivalent metal, does that matter? No. You just need to know that if it's in the gray zone, it needs a Roman numeral. Now I'm just going to go to our periodic table for a quick moment, because there have been some people who've been away for a while. Just to remind you where the gray zone is. Here it's red, okay, but here it's gray. So anything where you know the charges already, we know that groups 1, 2, and 3 are +1, +2, and +3. So we don't need a Roman numeral to tell us anything about the charge. If I say sodium ion, you're going to know that sodium is +1 because it's in column 1. You don't need me to say sodium +1, right? You don't need that. Same thing for this little mini staircase in here. Remember that there are 3 of these guys here, 1, 2, 3, in that column. So their charge is 3+, 3+, 3+. There's 2 guys in this column, 1, 2. So these guys are both 2+, 2+. And silver, there's only 1 there, so it's just 1+. Do they need Roman numerals? No, because you know what their charge is. However, let's look. And what if I said to you, what is the charge of copper? You would say, I don't know. What is the charge of iron? I don't know. Okay, there's no way to predict, and in fact, they can have more than one possible charge. That's why they're called multivalent, multi meaning many, valent meaning charges, multivalent. Ooh, wrong one. One more down. There we go. So we're going to have to use the same tool that we used back when we were using the gray zone with regular things. So first thing we do is we write out all the ions, back on page 49, the correct number of each. Okay, so for example, in our first example, we have SN, and then we have NO3 with a little 2 here. So, and there's no number beside the SN. So that tells us how many SNs do we have? 1. How many NO3s do we have? We have 2 of them. Okay, so we would write it down twice. NO3, NO3. Now here's just a picture to show you what that would look like. So we have SN, we don't know what its charge is, and then we know NO3. If we look it up on our table, everyone go look up NO3 and tell me what the charge is on NO3. It's 1 minus. Now remember, all compounds are what? Whoops, not compounds, compounds. They are neutral. The overall charge is equal to 0. So if I have a +1 and a -1 and a -1, what do those two make together? They make 2 minus. If my compound is going to be neutral and I have 2 minus, what charge do I need on my tin? I need 2 plus. And that tells me that the Roman numeral then is the Roman numeral 2. And we can do it without doing all the pictures. We can just write out the ions like we did over here. We can say each of those is -1. When I add up the total negative charge, I get -2. Total positive charge, +2. And then there's only one place for that to go. That's going to be 2 plus. And so this would then be tin. That 2 plus tells us that the Roman numeral is 2. And the charge, of course, goes in brackets. Tin 2, nitrate. NO3 is nitrate. Look that one up on your pink sheet. Would we like to see another example of this before I set you free? Anyone like to see another example? Yeah? Okay, I'll show it, but if you just want to ignore me and get on with your life, that's also totally fine. FeCO4. And the reason I like to show this one is this is where some people can get confused. okay? Because the first thing we have to do is we have to write out all the ions. How many Fe's? Just one. How many of these guys? And this is the tricky part. A lot of the times people will be like, oh, there's 4 of them, but there's not 4 of them. We have a single ion that has 4 oxygens on it, but we just have 1 PO4, which is phosphate. We don't have 4 of them. If we wanted to have 4 phosphates, we would write it like this: PO4 in brackets with a 4 on the outside. But if there's no brackets and no number on the outside, it's just 1. Okie dokie. So we have an iron. We have a PO4. Write out all the ions. Look up the charge of the negative ion. Okay, what's the charge of that ion? It is 3 minus. So add up your total negative charge. Not much to add here. It's just 3, so the negative charge is minus 3. So our third step was find the total negative charge. And then our fourth step, the total positive, is going to equal the total negative. So these two numbers should be the same. So we should have a total of 3 plus. And there's nowhere for this to go except for on this one here. So that is 3 plus, which tells us that the Roman numeral is 3. So now we name it. We have iron. We have a 3. And then we have phosphate. Okie dokie. So if you want to write quiz 5, I would suggest that you definitely practice at least 4.2c, but if you just want practice without the Roman numerals to start with 4.2b. So 4.2b has no Roman numerals. Let's just make sure. Does this have both or is it just one? This is all Roman numerals. 4.2c is all Roman numerals. And then 4.2d is a mix of Roman numerals and no Roman numerals. And that's what your quiz 5 would be on. So if you feel like you're really good, you can skip ahead to 4.2d. If not, start with 4.2b, do 4.2c, and then move on to 4.2d, just depending on how much practice you think you're going to want. All right, and I'll come around and help you out with stuff and get these quizzes marked that have come in. That's a good question. Yeah. Was it quiz 5? I have misplaced it. Would you mind doing it again? It'll be good practice for you, she says, trying to sell her mistake.
Do I have to do 5B?
Whatever you want. You can do 5A. It's fine. I don't care. You'll get full marks. Oh, yeah, absolutely. It's my bad. I'm sure it's on one of these piles of paper somewhere, but I feel like it would be easier to have you do it. Stephen. There you go. Raina. There you go. Quiz 5. I have a feeling I've put like a stack of them somewhere because Kita asked me the same thing. And so I'm going to go rummaging through all these papers and see if it's like buried in here somewhere. Yeah? Okay. Oh, hey, look, I found quizzes. Oh, maybe they're here. Oh, Kita, I found your quiz. Okay, we're good. I found the stack of quizzes from yesterday. Okay, phew. All right. And Kita, I have your quiz 6 now as well. And your quiz 5. This one? Who's your cation? It's either going to be a metal or it's going to be ammonium. So that whole thing is your cation. Yeah? That's the one you have to watch out for because it's different, right? Yeah. No, just like you just need to take like the A version of the quiz. Yeah. Isla. Sure, yeah. If you're done quiz 5, feel free to move on and work on quiz 6. Yeah, so for the second quiz, you add in these prefixes. So this is when you have a nonmetal and a nonmetal together in the compound. And so the only little hitch is that we only put mono on the second word, not on the first word. Okay? And all the rest of them, it's just pretty straightforward. However many you have, use that prefix. The first one and the second one combined, so it means you need to say, if I start with a metal, that's ionic, no prefixes. If I start with a non-metal, That's covalent, and I do use prefixes. Okay? Hi, Sunny. Thank you. Reina. So first of all, carbonate, not carbonite. And then this one, you misidentified that one as manganese, not magnesium, in which case it would need a Roman numeral. Okie dokie? Oh, absolutely, yeah. Mackenzie. There you go. That was your quiz from yesterday. Tomas. So for this one, just in terms of figuring out which the Roman numeral is. So sulfite, when we look it up, it's SO3 2 minus, and we have 3 of them. Yeah? So we go 1, 2, 3. So that means I have 2, 4, 6 is my total negative charge, and these two numbers have to be the same. So I think you got that far because you wrote 6, right? Okay. The only trick is, and this is what you would have to do differently, is to take this 6 and split it up over however many chromiums you have. Okay, so that would be the extra step you would need to do there. Okay, that would be a 3, exactly. And I think maybe, for this one, maybe you looked at that 3 and thought there were 3 of them, right? But there's really only one, because if we wanted to have 3, we'd have to do that. Okay, so there's only one carbonate, which is 2 minus, which means this is 2 plus. And since there's only one of these, we don't have to split up the charge. It all goes on to that one there. Okay, but not bad. Okay, good start. Oh, and I've got your other one here too. Yeah. So just be careful with this, that sulfate, it's a sulfur and an oxygen, so those both get their own capital letter. Okay. We don't put brackets if we only have one of these, so there's not like 2 of them or something, so there's no brackets. And then here we do need to have brackets because we want to have 2 of both the hydrogen and the oxygen. Yeah. And then finally for this last one, I'd almost always tells you that it's a single element, in this case, nitrogen. This would be nitrite, and that's nitride. Okay? Yeah. Okay. Oh, yeah, so you can definitely do that again. You've done 7A, so you can look for 7B. Okay? Yeah. Mackenzie.
These are all wrong. Like the chart.
Oh, they are all wrong. So that is page 43, number GHIJ.
I think it's just H to J.
H to J?
Yeah.
Okay, thank you.
And then you did F already, right?
Yeah, we got F already. Yeah. Yeah. Ella. This was from yesterday, I think maybe. Yeah. So I only put this here because I just wanted to point out that phosphorus, it's OO, sulfuric, it's UU. This one's correct though. Okay, so there's no problem with that one. I just wanted to point that out. And then ClO is hypochlorous, not hypochlorous. So, yeah. Okie dokie. Ooh. At 10:30. 10:30. Read. Just be 1 second. I just need to get this back to read and write it down. Nice job. 11. Okay. So this is CR207. Okay, so you just take the whole thing, CR207, and then you go, pardon me? Yeah, there's just one of them because there's no brackets. And you'll be able to find that one under the Ds. It's a little hard to find, but it is under the Ds in the polyatomic ion chart. Yeah, you're welcome. Alyssa. Just a tiny little spelling mistake. It's chromium, not chromium. Yeah. Haley. Haley, where are you? You're down here somewhere. There we are, and that's a quiz number 4. Okay, so for this one, just looking and seeing if it's not in the gray zone, then don't use a Roman numeral. Okay, so that was most of your marks, and that one you just forgot to change the ending to "-ides", so I think that was just like a little brain glitch. Okay, so you're good. All right. Benny. James. I got your quiz marked. And guess what? Perfect. Good. Okay, Benny. Okay, so for this one was just a little spelling mistake. Okay, so that's just silly. This one here, you have 2 phosphates. So you got your 6, but you forgot to split it up onto the 3 of them. Okay, so
yeah, I added
just
2
that.
here, but I just put 6.
Yeah, yeah. Okay. Yeah, yeah.
Thank you.
Ella. So the only thing is that when we have an A or an O, we drop it in front of the oxide. But other than that, it's perfect. Okay? Yeah. And that was Ella. If you know if it needs a Roman numeral or not, where is my yellow paper? I'll be right back. Yeah, gray zone needs them. And then the white zone or yellow zone does not need them. Yeah? Jessica. So just watch out if, yeah, those are in the gray zone. Okay. Need a Roman numeral. Okay. Haley. So these two are in the gray zone, so they need Roman numerals. Okay? Yeah. Stephen. Okay. So, first of all, single elements, so no brackets. Okay. Second of all, these ones need their charges balanced. So you've just kind of like got them like thrown down on the page, but this would need, like, what would you need in terms of how many Li's and how many O's? Yeah. Yeah, exactly. Yeah. Okay. Yeah. Hi. Lead is positive. And actually, let me just fix that for you. Where's my erasers? There they are. Okay. These ones are -1, 3. This is +1, +2, +3. And then these ones are 3, 3, 3, 2, 2, and 1. Okay? Yeah, but this only is for the non-metals, so it's kind of like, these two and then these three and then those. Okay. So lead is one of those ones where you have to figure it out by using, like, drawing out all your ions and putting the charges and then separating it out and all that stuff. Yeah. Okay. Hi. You can use this for quiz 5. Oh, yes. Do not memorize it. Thanks, Haley. Mackenzie. Mackenzie. Yay. James. Yay. Raina. Okay. Raina. That's very kind of you to take that to your friend. Ella. Oh dear me. Okay, so we need to have mono on the second word. We don't put it on the first word. Like here we didn't put it on N, but we do have to put it on the second word. Okay? Yeah, absolutely.
What do you use to find the Roman numeral?
So what you do is you would say, how many NO3s do I have? Nope,
Nope.
just one. So you say, okay, I've got NO3, and then I've got copper. Now you go look up the NO3, and you figure out what its charge is. So if I have one here, no, oh, I've got one folded to the right page here. Very nice. So you would look up NO3, and it's got a negative charge. Okay? And if that's negative, and you just have one of them, then your total positive negative charge is -1.
Also,
Yeah, +1. And so that would be copper 1. Okay? And then this one, you're going to have to write out a lot of things because there's 5 of those to write out and 2 of those to write out. Why don't you give that one a try, and then if you get stuck, show me. So Kyan and Matthew, are you guys going to be doing quiz 5 today? Excellent. Hi.
How do you know the charge of the bill?
Okay. So what you have to do is you actually have to literally follow through steps 1, 2, 3, 4, 5. So what you would have to do is you would have to write out all the ions, and you would say, I have 2 irons, so I write out Fe and Fe. I have 3 O's, so I would write out O, O, O. So far, so good? Okay. Step number 2, we're going to find the charge of the negative ion, because those ones we do know. We know that oxygen is -2. Okay. And we're going to write that in for each of them. So we have 2 minus, 2 minus, 2 minus. You're just turning in? No? You got a question? Okay. All right, and so we have -6. These two numbers, the total negative and the total positive, have to be the same, okay? So that's going to be +6. And then you have to say, how do I split that up amongst those? So each is...
That's how you get there.
Exactly. Yes. Yes, yes. And then you know that the Roman numeral is 3. Hi. Exactly, exactly. For that one, we need brackets, yeah. And actually also for this one, even though this one's tricky sometimes because it doesn't have a number to remind you that you need them, but this means you have 2 H's and 2 O's. Yeah? Okay, cool. Nathan. So it looked really good. The only thing was, I think you found this 6 here. You had phosphate and phosphates, 2 phosphates, and you forgot to split it up amongst the 3 of them. So each of them would be 2. Yeah. Okay. Nathan. Hi, Sky. Thank you. Jessica. Yeah.
If there's just one, if you've one prefix, you still use the prefix.
Ah, okay. So if we have a metal, that means that the whole compound is ionic. So we don't use any prefixes at all, not for the metal, not for the non-metal.
So if it's ionic?
Yeah. Yeah? Okay, cool. Sky. Oh. Okay. If you did not get up to quiz 5, study out that one over the weekend and be ready to write on Monday. Got stuff for me? Excellent. You want me to do them right now? Yeah. Nice. That's a 6, Leon. And here's a 5. Nice. All right. Thank you, Roy. Roy, I got your quiz 3. And I got your quiz 4. Okay, let's see, Riley. Okay, so for this one, you just forgot the mono on the second word. We do need mono on the second word. Not on the first
Oh.
word, but we do on the second word. Okay? This one, you had Roman numerals for everything. You have to remember that we do use Roman numerals for the ones that are in the gray zone, but for example, silver is not, so no Roman numeral.
Yeah.
Aluminum is not, no Roman numeral, and somehow or other, that's sodium. That was just I think a brain fart.
Yeah.
Okay, so yeah, other than that, it's looking pretty good. You've got the idea of how to find the Roman numerals, which is the tricky part. So yeah, just next time you do it, just check and make sure if they are or aren't in that gray zone.
Okay.
Yeah, and that's it, I think. Yeah.